All right, everybody. Hi there. Oh, I think my my background is still there, but I didn't mean to have it. How is everybody? Hi there, Green Yoshi X. Great to see you in the audience. I remember you from the last stream. And hi there, LNGBR. Will you show us how to use today's software? And the answer is absolutely. In fact, today we're going to have a great session together. Oh, Elena, great to see you. Or Elena. Yeah, thank you for sharing your name. And Shrey, hi. Yeah, I love to see some familiar faces, but we also see some new faces every time. And that's what makes it great to be in this community. We're very welcoming and ready to learn. Hi there, Code Marvel and Pharaoh. Yeah, so today we're going to be having part 2 of our Taipy workshop. And what that really means is that I'm going to take you through a little bit more of this review of what we did last time. And then I'm actually going to move into some more interactive and machine learning style content. So, last time we built a Hello World program in Taipy. And this time we're going to take it up a notch and we're going to actually do a review quiz. And then we're going to move on to data visualization and machine learning, which is some of the things that we were interested in from last time. So first we'll start with a review. As Code Marvel says, would love a quick review. So I'll send a link to the review quiz in the chat. It shouldn't be too bad if you were here for last time. And I'm also going to ask you for some input on what you learned last time. So go ahead and fill that out. I'd love to hear a little bit from you before we get beginning. And I also want to make sure that everybody has the check-in link. It's at the bottom of this form, actually, but I want to post it in the chat as well to make sure that everybody has it. It's events.mlh.io/events/11003. So if you don't have that already, please make sure you do. The reason we ask you to check in is it's twofold, really. We want to make sure that you are getting points for Global Hack Week and getting that swag, that sweet swag that everybody loves. But we also want to make sure that you're interested in the content. We want to gauge who's coming to which workshops. Is this a good time to be hosting the workshop? Are people going to, be able to attend live? And so for those reasons, check-in also helps us to sort of understand where you're coming from too. But yeah, so once you finish this review quiz, we'll go over it together. The goal is really not to give you a grade for these sorts of things. You get enough grades in school. The goal for this workshop is really just to take the quiz so you can identify whether you're learning and just double check that you're making progress in the class, or in the workshop, I should say. It's not really a class because like I said, there are no grades. So yeah. Anyway, so we have a decent number of you here in the audience, and I just want to plug this one more time right now for anybody who's joining a little bit late. We're filling out this form, the one that's on the slides right now. It's the review quiz from last session. And we're checking in. We're making sure that everybody is checked in for the workshop. That link is events.mlh.io/events/11003. All right. Okay, so once we finish this review quiz, we'll go over it together, as I mentioned. And let me check how many responses we have so far to the review quiz, just to get a sense of where folks are right now. And yeah, so we have about 4 responses. So we might cap it soon. And in the first element of that form, let me actually take you to that form so you can see it for yourself. Present, share screen. Yes, here it is. So the first question is, did you attend part of the workshop? The first part. And if you did not, you can watch the recorded version on twitch.tv/MLH. And that goes for any of our workshops this month. They're all going to be available via Twitch. And so feel free to watch the recorded version on your own. Maybe it was at an inconvenient time for you. Maybe it was, just you had a little bit too much going on, and or you missed something live and you'd like to review it again. It's all there. So I'll say yes to this. And okay, so why don't we now go to the responses? And I have a few responses from you all. So I'm going to share them. Hopefully you all can see here. So first, did you attend the first part of this workshop? Actually, most of you did not. So that's okay. We're going to actually go through a lot of this, and we're going to review what we did last time. So don't worry about that. Okay, and then true or false, a node is a Taipy element that is composed of several tasks. And 80% of you wrote true, but actually that's not true. So let's go into our slides, since some of you were not here for the last time. And I'll show you the correct answer here. So it was on slide 13 of our last workshop. And we had an initial project. And we had that a Taipy scenario consisted of nodes and tasks. All right, so well, a scenario is what is composed of nodes and tasks, and there's sort of two separate things. So we did a Hello World project last time where, you gave your name as a node and then placed that into the build message task, which processed the information and then returned a message in the message node, which would be the output node. Okay, so tasks are really kind of, you could think of almost like functions in programming, and nodes would be like variables. I guess that would be the best analogy. And so when you're looking at nodes, those are sort of, where you're going to access data, read it, write it, and things like that. All right. So that's the answer to question 1. True or false, a node is a Taipy element that is composed of several tasks. It's actually false. Okay. And then I asked, what is the correct way to update the state in a scenario? Okay, so remember, a state is a particular user's instance or session in the program. So for example, if you have the Hello World application, a state for me would be the name equal to Stephen, and the message would be hello Stephen, right? Because that's my name, but your state would look different. And that's to make sure that we don't sort of run into each other on the same web application, that many users can have a session going at the same time. So I asked, what is the correct way to update the state in a scenario? And let's see, 71% of you wrote scenario.variable.write state.variable, and that's correct. Okay. Excellent work with that. So what you're doing there is writing the state variable. You're writing to the state variable from the scenario variable. Okay. I actually think maybe this is backwards. Oh no, this is correct. Yes. So you're getting from the scenario to the state. All right. And now I asked, which of the following is a Taipy control? And there were 5 choices here. And actually, we have a pretty even distribution here, folks. So there are quite a few answers here that are correct. There's box, which is correct. And there's button, which is also correct. Oh, I'm sorry. Actually, I think box is not correct. Let's check that out one more time. We can go to our controls in Taipy. So it was button. So a button is a control that can trigger a function when pressed. But I don't see a view or a task or a box here, unfortunately. So it's going to have to be button, and the other 2 would not be. Okay. And Pharaoh says, I may have missed this if mentioned earlier. Is there a way to access the slideshow? So I'm going to post the slideshow at the end of the session. And you can also look at the recorded first part, which is available on Twitch. And you can essentially flip through that video to find the slides. So yeah, sorry, I just don't post it ahead of time because I don't want people to look ahead and look behind. And I want us all to kind of stay synced up to the same slide. But that's a good question. Thank you. And yes, Lahaini says, I think it's button. That's right. Okay, so now we're going to move on to the next question. So hopefully you all can see again the quiz. And this is my fun question that I always like to ask. Global Hack Week is truly global. Just for fun, tell us which continent you are logging on from. Okay, and this was an optional question, but I love to always just see where everybody is coming from. And this time we have a super, super even split between North America, not South America, Europe, Asia, and Africa. And I think Africa hackers have us as the most right now. So excellent representation there. I think actually it's been different every single time I've asked the question during Global Hack Week. So I think the first time I asked it was majority North America. The second time I asked it was majority Asia, and now it's a plurality Africa, which is really cool to see how widespread our community is. And finally, I wrote, don't forget to check in. So if you haven't checked in by now, maybe you just aren't planning to, and that's okay. But I would encourage you to check in next time as well. Yes. All right. Well, folks, so thank you once again for joining. And I want to let you know that if you need to catch up and you are feeling a little bit behind, I want you to know that the Taipy tutorial Python file from last time is still available. I'm going to share the link in the chat. This is all the work we did last time to build a Hello World application in Taipy. So if you're feeling behind or you didn't get to catch the last workshop, I saw 80% of you did not get to catch the last workshop. You can get that here. But yeah, Green Yoshik says, wow, what an amazingly diverse crowd. I know, it's amazing. Thank you all for being here. And Joan shares a dinosaur. I love that cute dinosaur. It reminds me of the Chrome Dino. Does anybody ever play the Chrome Dino game anymore? It was super popular back in the day. We have, actually, I saw there's chromedino.com where you can play Chrome Dino online. Let's see if we can play for a minute. We should maybe play this as a, could we play this as a mini event? I'm not sure. Oh, I just found this actually because your dinosaur made me think of it. Oh, you can play Mario. That might be a copyright issue, actually. Sure. Man, I wish we could play this multiplayer. I think we should try that one stream. Don't you all think? That would be cool. Elena says, come on. I know, I'm not very good. I'm sorry. I really can't play that game for the life of me. But yeah, we could build a dino multiplayer game. See, this is what I want. I want like a dinosaur on the top, in the middle, and the bottom, and we could all play together. I think that would be so cool for a mini event. But yeah, anyway, that besides that brief digression, I guess we'll move on. But I just want to make sure that you all have this link so you can check out this. Oh yeah, that's right. Games Week is next month. So maybe we'll build that in Games Week. I'm not sure. Or somebody in the community. But so now I want to move on a little bit and talk about charts with all of you. So a chart is a key element of Taipy. It lets you do data visualization, which is the ultimate goal of this series. We're building data visualizations for our machine learning projects, so we better know how to do a chart, right? But we're going to start by building the hello world of chart apps with Taipy. All right. And that means that it's going to be the minimum possible example. So if you haven't already, you're going to need to get your Taipy environment configured. And so we'll see part 1 for that. And let me actually, in my Visual Studio Code, I'll show you how to kind of get started with this. So let me share my Visual Studio Code. Put that front and center so that you all can see it. Sometimes it's really hard to see Visual Studio Code. All right, hopefully you all can see this now. But the first thing we're going to do is add a new terminal. So you can do that by typing run. Let me just save this as our Taipy day 2. And here's our terminal. Okay, so for this case, we want to make sure that everything is installed correctly. And the best way to install Taipy is by typing pip install Taipy. Okay, and so I already should have this. Sorry, I need to go into the correct virtual environment. Actually, maybe it would be good to show you to install Taipy. So I'll just install it on my base environment. Hopefully it doesn't break anything in my base environment, but yeah, so you can see how Taipy installs. It installs the GUI, which is super important for this. And you can see it's also installing Flask, and some Flask elements. That's kind of interesting. I wonder if Taipy has any relationship to Flask. It wouldn't surprise me at all. And while we're waiting for this to run, I want to actually answer some comments. So Coke Marvel says it could be like the car race game, and it could be last player standing. Yeah, that would be really cool for the Chrome Dino game. Elena says, I hope you're going to show us how to use Taipy. Last time it was 3 a.m. in Romania. That's way too early. Yeah, I'm glad that you're able to join for this one a little bit later, I think, now. And then Defendant says, I went to UT's sessions and we learned about Streamlit. It seems like there is some overlap between Streamlit and Taipy. Can you tell us the difference when we might use one instead of the other? And yeah, I'd be happy to tell you about that. I think that it's really going to depend on your own preferences. You might have more, competency in one or the other. And, ultimately it's up to you. But there might be certain ways that the architectures are better or worse for different applications. So I would just recommend reading some reviews online of, should we use Taipy or Streamlit? I'm sure there's a lot of nuance to it. I also think Taipy is a little bit easier to get up and running with, generally speaking. So you can kind of get started much quicker with Taipy, in my opinion. But I think it's going to really depend on person to person. Yeah. But anyway, so you would need to finish installing this. But when you type pip list, it should now show Taipy. Let's see. Hopefully it does. Yep, there it is. So you can see we now have Taipy, and you can verify that on your own system through pip list. And another thing, if you want to use Google Notebooks, I think you can also use Taipy on Google Notebooks, but the syntax is a little bit different. So there's a way to do that. And Andy says, can we use data spell instead without any issue? I'm not sure what data spell is, actually. I've not used that before. Oh, I see. It's on JetBrains. I think you should be able to use that. Just try installing Taipy and see what you get there. So I realized that my little icon went away. I always debate this, because if we do it this way, then the screen is smaller and it's harder for you to see. If we do it this way, I might be blocking some important information. And if I do it this way, nobody can see me. So I tend to sometimes alternate between them. But yeah, maybe I'll go back to this for now. But all right, well, now that you have your sort of library done, we can import some of these libraries. So I want to just first, for this demo application, we're going to go from Taipy and we're going to import GUI. Okay, this is a module. Oh, sorry. Import GUI. This is a module in Taipy that allows us to use graphical elements. Oh, Joseon says data spell comes with Anaconda. Okay, that's cool. I didn't know that. I'm sure that you can use that instead of Visual Studio Code, and it'll be just fine. All right, yeah, thank you, Code Marvel, for sharing. That seems like it would be a good comparison. I haven't read that article, but yeah, I'm sure they've thought about it a lot. So thank you for that. But all right, so let's go back to our charts here, and as I mentioned, we're importing the GUI module, and we're going to add some data to this chart. We can't plot anything unless we have some data. So the way that the Taipy documentation suggests that we build this hello world is by doing a list and plotting that list. You can plot lists in Taipy, actually. You don't need any fancy data structure. A list will do just fine. So let's build this list. I built a list that's going to be x squared for x in range 1 through 10. So that means it would start with 1 and then go to 4 and 9 and 16 and 25 and so on, kind of in this quadratic increasing way. So let's code this up. We'll type list to display. And what we're using here in this next line is what we call a list comprehension. I'm going to zoom it in a little bit for you. And the idea here is to write the code in terms of one single list, and we're putting a loop inside of there. So we'll type x squared because that is the operation we want to do for every situation. And then we type for x in, and I suppose we type range 110. But you could actually make your function anything you'd like. If you'd like to make it 3 plus x squared minus 2x, that's fine. Let's do that. Why not, right? Make something a little kooky. All right, but now we can move to the next line here, and we'll type GUI, which is a GUI object, and we need to tell the GUI what we want to plot. And the way we do that in Taipy is by passing a string that could be one of three things. It could be Markdown, it could be HTML, or it could be, I think, a little bit more advanced of an object. I'm sorry, I can't remember right now actually what the last thing is that you could pass through. Let me see, actually, it must be in my slides somewhere. Oh, I think you can just pass in a string. But yeah, we're going to pass in some Markdown. And what we'll do is pass in the following string. So it's going to have tags. And the tag is going to be a chart. It's going to indicate that we are using a chart. So we'll type chart. And this first pipe will tell us what data to display. So you can see we're using pipes, these vertical lines, to segment our Markdown and tell Taipy exactly what we're intending for the layout. And we'll type list to display in this first section to indicate that we want to display that Python list as the data on the chart. And after chart, you can actually add a bunch more pipes to add more colors and other things. But for now, we'll just type it like this so we can run the GUI and just get started with our hello world. All right. So all you need to do then is type run Python file, and you can see it compiles everything. And you should get a really simple chart. Let me show you that. All right, so you can tell now that a plot is generated of the x squared, or whatever function you chose to plot. And Elena says, why doesn't it see the list to display in brackets? So I think you are referring to why doesn't it see the list to display in brackets? Or if you're referring to why this needs to be in brackets, it's because instead of being a part of the string, this is actually going to be substituted in here. So you could also alternatively write it like this if you wanted to. Actually, I think you would have to write it literally like this: 1, 2, or 1, 4, 9, 16, 25, and so on. But you could do that. And yeah, of course, I'm totally happy to give you this code. By the way, I should be sharing the part 2. Let me move it back to this minimal example here. I should be giving you the part 2 codes. I'm sorry I didn't do that. Let me share that right now so that you all can follow along, because I know how frustrating it can be to not have the code and just kind of have to copy off of what I'm doing. So I just sent that to you. This is Taipy tutorial 2 for you. And this should cover all the codes that we'll make for the rest of this workshop. So if you fall behind or you aren't quite sure what I'm writing, you can look at this code and it will tell you the entire solution for the day. All right, so we'll go back to our chart that we built, and you can see it's super involved already, and has these graphical elements, and all we had to do was write about 2 lines of code. And so that's showing us sort of what it's like to use a framework, a web development framework such as this Taipy. And how do we see the chart is the question. So all you do is you type the code in your editor, and then you simply run it. You can use the triangle key here to run the code, and it should immediately pop up in your browser. If it doesn't pop up in your browser already, you can type this in 127.0.0.1/5000, and that should get you there. But yeah. So I'll just type it one more time. You can see it runs here, and we'll open up your data. Mm-hmm. So let's actually click on this link here. Control click to get there, and then I'll show you on the screen. So I think you all can see now my web app, and you can see even there's an interactive element that shows you each marker, and you can use these things like box select to do something, take a picture, zoom, whatever it might be. But yeah. Okay, Elena says, I don't have that button. So Instead, what you can do is in your terminal, do you have your terminal open? Because inside of your terminal, what you can do instead is type the following command. So let me show you what command is causing this to execute. It's this one. So I typed in the directory where I have my Python. So here it is. So you'll probably have your Python also at user bin Python 3. And in fact, a lot of the times you can just type the word Python or Python 3. You don't need to type the directory where it's located. But so you'll type where your Python is, and then you'll type the source of your Python file. So right now I have this taipy day2.py file stored directly on my Stephen Cropper folder. So my user folder. And you might have yours in your downloads or your documents. You're gonna have to look up here in the top of your Visual Studio Code to really see where that directory is. But then once you type the directory and you type the name of your file .py, you can just hit the enter button or the return button on your computer, and it will execute the code for you. Yeah, so that's sort of how you execute any Python file, by the way, is by doing that. But all right, so we're going to move on a little bit now. And if anybody has questions, of course, please feel free to reach out. I love it when folks ask a question in the chat, and we can actually help address that live. That's one of the best benefits of having this live. Instead of going on YouTube and looking for a tutorial on Taipy, I'm sure you can find one, but you know, the fact that we can troubleshoot live is a huge benefit that we have here. But yeah, so all right, we're going to now look into a few notes about charts, because we've just built our first chart, but we don't really understand what they are yet. And okay, so this is what I was looking for before. What charts can accept. So charts are built on top of the Plotly Python framework. So this is an entire library dedicated to building plots in Python, and Taipy is making use of that for their plots and their charts. So anything in Plotly that you can do, you can also do it in Taipy. And so the documentation, I've put a link there. I'll put the link in the chat too. Let me just put that in the chat so you all can check it out. It's really a great library for doing all kinds of plots. It's similar to matplotlib. If you've ever used matplotlib in Python, you kind of have already used something similar to Plotly. But yeah, so these charts accept NumPy and data frame objects too, in addition to these lists. And those might be even more useful than our list, to be honest, because they can contain more data. And generally speaking, it's easier to manipulate a NumPy array, or especially a data frame, when compared to a list. There are more built-in functions that allow you to edit that data, process that data. So it's probably a little more useful to actually use NumPys and data frame objects. And in fact, we're gonna do just that in the next section of this workshop. I want to also mention the marker keyword argument. So this is something that will go after the chart pipe in a separate pipe on the right, just as I was showing before. And this marker keyword argument is a dictionary with the following keys. It could have size, color, symbol, or opacity, really any of these to help you make your chart look prettier, easier to read, more targeted towards your reader, and just generally a better chart. And we will use the properties of this chart object to build our ML-driven data visualization. All right, so why don't we get moving here? So we're going to switch our gears to ML model at this time. Elena says, is there an online environment that might help me see the results? Yes. So there is, I'm actually not sure if DataSpell, Andy, did DataSpell work at all for you? Maybe, Elena, you could try DataSpell for this. You could also try to use a collab notebook. I might actually try to get this going with Gitpod as well. I just learned about Gitpod recently. Let me try putting this online for you. Just give me 1 second to try this, because I think this would be a really useful thing for us to have. Let's go to GitHub. All right. I'm going to upload these to GitHub. All right, so I'm going to share this GitHub with all of you. Just give me a second here. Alrighty, so I just put this on GitHub. So now you can go and check that out for yourself. And there's this thing I found recently called Gitpod. So Gitpod will allow you to use a virtual environment. And actually, let me see if I can get this working with Gitpod. So let me show you Gitpod. Oh, it says error 404. Let me see. Oh, it's because it's a private. Sorry, I have to make this a public repository. Give me 1 second to change this to public. I have to do the two-factor authentication thing on my GitHub. Sorry, everybody. It's just live demo stuff. But it should have worked now. So let me know if you can see the repository. And I wanted to show you this Gitpod thing. So what I do is go to gitpod.io, and you can click try for free. And you won't have any, you won't be put immediately to this website, but this is the workspaces for Gitpod. So I think you get 50 hours for free on Gitpod. And let's click a new workspace, and we'll type in this repository that I just sent you all, Taipy workshop. All right, let's see. It says no work. It says actually no. I wonder why it says there's no. Oh, there it is. All right, so let's click continue here. All right, so now when you click on this, you have a terminal. So you can type pip install Taipy. Hopefully you can all see this. It's a little bit a little bit small. Sorry about that. Let me shrink this down for you so you can actually see what's happening on my computer. Really sometimes can be hard to see. But all I did was type pip install Taipy, just like I was talking about earlier. And Doreen says, what is the main use of Gitpod? So Gitpod is just to help you if you are having trouble with getting started here. It should be able to help you get going with an online interface. Someone in the chat asked, Elena asked about having an online version of this. So yeah, hopefully that could help. Let's say. So if I type Python in here, it tells me that I have Python. All right, that's good. So let's see. Where did that terminal go? So all I need to do now is type Python and then Taipy tutorial 2. Or let's try Taipy tutorial, which is from yesterday. Oh. I didn't recognize that I installed Taipy. Let's try again. All right, well, maybe this isn't a great use of time to keep going with this, but if you want to try that out, Elena, maybe it would work for you. I'm not sure, but all right. So Anno Expected says, hello, Stephen. I really wanted to attend your live sessions, but time zone doesn't permit me. It's already late at 2 a.m. I'll watch the recorded session tomorrow. That's great. Thanks for sharing. Have a good rest. And I will see you. I will catch you on another stream when the time zone is good. I think we have streams all the time, every month. So yeah. All right. So we will take a break from this Gitpod thing. Unfortunately, I don't think it's really a very fruitful way to go. But if you're having issues with your environment, I highly recommend you rewind and see the steps, follow the steps. And that, I think, will be the way to get working on a local machine. But all right, so we have this data, the old faithful geyser eruptions. And this is actually a data set from Kaggle, but really it's from the National Park Service. They track these eruptions that happen at the Old Faithful Geyser in Wyoming. And it's a big geyser in the ground that erupts quite frequently. It erupts every couple hours, actually. And the data set has two features regarding these eruptions. It tracks every eruption's length, which is in minutes, and it tracks the waiting time between eruptions in minutes. So it has both of these variables. All right. And one more question about Taipy. And you get a error. The pandas version installed does not match the supported pandas. All right. Well, I would recommend then you can use. Do you have Conda, Elena? Because if you have Conda, then you can use Conda to install a new environment. Okay. Yeah, sorry about that. I'm sorry it's not working for you. That's really frustrating. I think it's an error with the environment that you're in. Let me see what version of Pandas I have, actually, before I let you go with that. Let's see. So when you type pip list, you can get a list of all of the different libraries that you have. So my version of pandas, because that seems to be the error you're having, is 2.1.4. So you can install a specific version of pandas by going like this: pip install, and then install a specific version of pandas. Okay. Actually, I think you need to use two double equal sign, and then it will work. Pandas double equal sign 2.1.4. So I would recommend starting from scratch, doing that, and then after you install pandas that way, then type pip install Taipy, and that should fix your issue. But let me know if it does not. All right. But that's a great question there. I'm sure a lot of people have version issues. So don't feel bad if you're having version issues. I'm sure many people are. Unfortunately, that's one of the biggest drawbacks with Python and its libraries, is that all the versions kind of get mixed together and confuse each other. So I'm sorry about that issue that you're having. But all right, if you want to download this data on your own, you need to go to kaggle.com/datasets/janithwani/oldfaithful, and I'll paste that link in the chat as well, so you can download this data set. It's also available on my GitHub and maybe I'll also place it in that very same repository. You know what? That would actually be a good thing to do, don't you think? So I think I'll do that. Let me just do that really quickly. All right, it should be uploaded there now, so you can see the data set on the repository. Okay. But yeah, so we will now build the ML model, and we will not focus too much on this, but the model that we're implementing is what we call a k-means clustering algorithm. And k-means is designed to characterize the eruptions as category 1 and category 2 eruptions. And this is justified since the distribution of eruptions is known to be bimodal, meaning that there are two common types of eruptions. All right, and I put a video, which is going to give you a link to a previous workshop that we did for another AI week called Classification Workshops, where we actually dive really deeply into this algorithm and implementing it, the assumptions underneath it, and this data set. So check out this video if you're interested more in that. But today we're going to not spend too much time thinking about the model and how to implement it. Instead, we're going to focus on how to visualize the data. Okay. So we will need some additional libraries for our ML model to run properly. So we're going to need to install the following libraries. We're going to need to pip install NumPy. So you do that in your terminal. You just type pip or pip3. You might need to type pip3 if it's not working for NumPy. And then you'll type pip3 install pandas. And so these are libraries that are primarily used for data structures and data manipulation. So let me actually move to my terminal here, and I'll show you how to do that. Just type pip install NumPy. And me, it says requirement already satisfied, but for you, it might not. And then you type pip install pandas, okay, which will install your pandas. And then I also have another library here, sklearn. And this one is actually for our machine learning algorithm. So sklearn stands for scikit-learn, which is a library in Python that you can use for machine learning applications. So what you'll do is type in your terminal pip install scikit-learn. And I'll do that as well in my terminal. So let's do that. Pip install scikit-learn. Perfect. All right, so we can import these libraries into our program just like we imported Taipy there. So what you'll do is type import type numpy, and then we use as to create an alias, kind of a nickname that we can use to call this numpy library whenever we need it. So we'll just use np for short. And pandas, I just called it PD. And then finally, we'll import a k-means clustering algorithm, which is going to be from sklearn.cluster module, and the k-means model is what we're importing. So you type from sklearn.cluster, import k-means. All right, let's try this out. So we're going to type from numpy, import numpy as np, sorry. Type import pandas as PD. I think we said from scikit, or sklearn, sorry, .cluster, import k-means. Okay, so with all of those methods written out, we should then have enough for this project. We might need to import some more things from Taipy actually, but we'll get there later. So first, because we want to focus right now on our machine learning development. So first, we're going to read in the data using a pandas data frame object. And this is where we read in the data set called faithful.csv, which is the one that we have in our local machine. It's all that machine learning data that we're going to use. And we use pandas library to read that in. So we use pd.read CSV and then the pathway to the CSV file. So it could be in your downloads, could be in the same directory depending on where you place that, but we'll just type pd.read CSV there. All right, so I'll type that as well. That should work out great. All right, so the next step here is to store the values of this data frame in a format that is readable by the k-means clustering model. So in the case of the k-means clustering model, actually it does not really play well with the data frames. Instead, it's asking more about the numpy arrays. So what you'll do is type df.values. That will transfer your data frame into a numpy format, numpy array format, and we'll store that result as X. And we use capital X typically because this value is a matrix. It has rows sort of that are different data points, and then the features of that data point are captured in another dimension. So we'll put the weighting and the eruption variables as features for each of these rows, which will each represent one eruption. All right, so let's go ahead and do that in our code. By the way, this is something you can do without importing Taipy. So you don't need Taipy for any of this stuff. If you're still having trouble importing the Taipy module, you were able to import NP, PD, and k-means, then by all means, it's totally okay to use that. It says, would you mind explaining about install sklearn again? I have this error when trying to install. The sklearn PyPy app package is deprecated. Use scikit-learn rather than sklearn for pip commands. Yeah, I'm totally happy to explain that. Thanks for the question, K-Twitch, because I think you're probably not the only one to have this issue. But if you remember in my terminal, I typed pip install and then I actually typed scikit-learn. So I didn't type sklearn in my terminal. That's a really common mistake, and actually I used to make this mistake all the time because sklearn is the name of the package, but it's not how you install it through pip. So you just have to type pip install scikit-learn, and I'll type that command in the chat as well so everybody can get that. Yeah, no problem. All right, so once you type that, it should install everything. And let's go back to line 8 where we're defining this feature list, and we said it would be the data frame dot values, which converts all of these data into values of a NumPy array. All right. So then going back to our slides, this is representing our training data, and k-means clustering is an unsupervised algorithm, which what that means is that there's no need to define or label any targets for training. We just need these two features, and then the model itself will come up with some categories for our data. We do not need to tell it anything about those categories. And it's kind of a cool thing to have these unsupervised algorithms. And, actually ChatGPT, in a sense, to some degree, some components of it would be unsupervised learning. So it's a technique that is very relevant. But in this case, we're doing a really simple version of machine learning where we optimize for one thing, and we just find those local maximums to cluster the data together into two groups. All right, so let's go a little further with this and construct our k-means model. So this code here is actually defining the particular k-means model that we want for this application. It's going to be a k-means model with two clusters and random initialization around the centroids. So that means that we will just randomly pick two places to start, and then the algorithm will move us into the right location. And I said max iter, because that will tell us the maximum number of iterations that we want the k-means algorithm to be allowed to do before it arrives at a solution. So if you have all the computing time in the world, feel free to set max iteration to 1,000,000, let's say. But in this case, I think you'll want to pare it down to some defined number. And 300 should be good enough anyway, since we only have a few data points. Yeah, I think this data set is about 100 data points. So you can usually use the size of the data set to figure out how much training time there really should be for a given algorithm. But yeah, all right, now let's actually write this up. So it's going to go in after our training data set is defined, and we're going to write k-means, which will be the model object, and we initialize a new k-means object, and we're going to type in the different parameters associated with this model. Sometimes we call these hyperparameters because they are going to be the parameters that govern the behavior of the algorithm. All right, so our parameters are in now, and we'll type k-means.fit. And so this method is going to fit our data, our feature data x, into the k-means model and optimize for a particular goal. In this case, the goal is to find two categories that are going to sort of explain all of the data as best as possible. Okay, so the reason is because typically at this geyser, the eruptions last short time or a long time. So we want to classify those eruptions based on short time and long time. Yeah, actually, maybe we should watch a brief video so that you folks are not lost in this. Let's actually watch that together. I think that would be a really good use of our time. Let's see here. All right. Here's the video, everybody.
normally go on vacation, they have a schedule that they use. So we're going to have lunch at noon or 1 o'clock. We're going to go scuba diving at 3 o'clock. And we're able to use the clock to base our activities on. But here at Old Faithful, we don't use the regular 12-hour clock that everyone else uses. It's all about Old Faithful. So when people choose to have their lunch or their dinner or their nap or their walk through the geyser basin, all is based on when the Old Faithful is going to erupt, so they can be sure and see it. Old Faithful is getting ready to erupt, so I am trying to time it. Oh, and there it goes. So I'm hitting the stopwatch, and I'm noting the time on the atomic clock at 12:58, which is pretty good considering that the prediction was 12:59. So we're getting closer and closer. Now I'm going to measure Old Faithful. So as the plume of water gets higher and higher in the window, I'm comparing it to this tree right over here. And I'm using this picture, which has a triangulation setup, to identify how high the water went on the tree. And what I figured out, Old Faithful's hit its peak already, was that it came to about right here, which is about 140 feet. So in the logbook, in addition to the start time, I'm going to record 140 as the height of this Old Faithful, which is the tallest one today, which is kind of nice. And then all I need to do is keep an eye on the timer and see how long Old Faithful lasts. And that's all going to determine how we predict the next one. I'm also going to record the interval between the last Old Faithful and this one, which is 89 minutes. We take those intervals and we use those to make our average. Basically, we use observational Old Faithful to figure out how to predict it. And it changes through time. Just a couple weeks ago, we were using 88 minutes for a long eruption. And now we're using 90 minutes because we figured out that that was going to give us the better average. So Old Faithful is now been going for 1 minute 48 seconds. It's still going strong. If it lasts longer than 3.5 minutes, then we have what we call a long eruption, which is the most frequent form of Old Faithful eruptions. It's a bimodal geyser. It has longs and it has shorts. If it's going to have a short, I would expect that any minute now, it would just suddenly stop. If it were to do that, I would go ahead and predict it for 62 minutes, but it looks to me like it's probably going to be a long. Still a lot of water coming out of it. We're at 2.5 minutes now. So we're going to wait another minute and make sure that Old Faithful is a true long. We're getting to the point where the water's pretty low right now. So I'm going to be using the binoculars to determine the difference between the water and the steam. We won't consider the eruption done until there's no more water coming out. So we're still getting kind of big spurts of water coming out of Old Faithful. Most of the people have turned away now. And we are at 3.5 minutes. So we're going to consider this to be a long eruption, but I am going to wait and record. Okay, and it's done. So 3 minutes, 42 seconds. So our start time was 12:58. So our next prediction would be go 1:58 and then go to 2:28. All right, 2:28 in the book. And then the next thing I have to do is tell the world. This is 724 Victor with the Old Faithful prediction. Old Faithful geyser is predicted to erupt at 2:28 p.m. plus or minus 10 minutes.
All right, everybody. So hopefully you were interested in that video. I saw the Nile said that's really amazing. I know it's kind of cool how they're able to take that data, and it's really taken by humans. So you have to think about the quality of this data as well in terms of, it's actually prepared by a pretty meticulous record keeping over the years, and it's you can't really create something comparable with a machine-based approach. And defendant says, I'm not that good at math. To do data analysis, is it enough to understand the intuitions of the algorithms, or should I have a strong background in stats? So I would say that for data analysis, what's really important is to understand the assumptions of the model. So understand the assumptions of the model. So understanding the assumptions of the model is going to be huge. If you don't know what your model relies on, then applying it to something is going to be kind of a shot in the dark. For instance, think about if you go to buy a new car, but you don't know what kind of gasoline it runs best on. How frequently do you need the oil to be changed, and the tires to be changed, and what conditions is it good to drive it under? Then yeah, you have a car. It's very powerful, but in reality, it might not be the best way to use it. And yeah, Ron Axtell has a great answer here too. Don't worry about understanding it. It's most important to know about the first principles about the structure of the model. Exactly. If you can understand, okay, what are the basic building blocks and assumptions, that's going to be good. Ajax says, this looks like the perfect application of ML, vision type models, to classify long, short, start time, stop time using YOLO instead of a human. Yeah. I mean, that would be kind of cool to build such a thing. Yeah, computer vision could be a great application. This could be a great application for computer vision. But today we're using clustering algorithm. And when we apply this model, we get the following results. So actually, let me move myself so that I'm not covering the data here. But what we're doing is we're going to fit this data. So let's run the code actually. But before we do, I want to print some of these things. So we'll print cluster centers to get a sense of where our clusters of data are going to show up. And we'll also print cluster centers. So we type k-means dot cluster centers. That's an attribute that's already there for k-means. Right. And we'll also type, I guess we can type it this way if we want. We could also just leave it that way because I think it will print them both. But we'll also print out the standard squared errors, SSEs, and we just type k-means.inertia. All right. And then finally, we print number of iterations. And we could type k-means.n-iter. And that will tell us how many iterations it took for the model to optimize. All right. And you can feel free to run this yourself by clicking on the triangle. But what you should get is the following information. So there should be one cluster at around 2 minutes of length and 54 minutes apart. That would be considered our short clusters, our short eruptions, excuse me. And then another cluster at 4 minutes and 80 minutes would be our long eruptions. Okay, so you can see that the clustering algorithm has already sort of picked out these short and long eruptions that the park ranger was telling us about in the previous video. And then the standard squared errors is telling us the loss function. So this is what the algorithm is optimizing. It's the distance between all the points and the centers of these clusters. And that's 8,901. So it's not really a very meaningful number to us on its own, but it just know that the algorithm is trying to make that number as low as possible. And to get to that low number, it took 5 iterations of the algorithm. Okay, so that's sort of the idea here. And let's now check the result of our fit. So you can use the flags variable. I just defined this new variable flags. and it's the labels attribute of k-means. So to get that, you just type k-means.labels. So I'll type flag. I think I wrote flags equals k-means.labels. All right, and we can go further and notice that, like I said on this slide, the output of this will be zeros and ones. So the zeros being those short eruptions and the ones being those long eruptions. Or for you, it might be slightly flipped. But yeah, so you can go further and define two categories. So category 1 would be the flags being 0. It's the data where flags is equal to 0. And category 2 would then be the flags equal to 1. Okay. Yeah, Ronak still says, I tried to apply this algorithm for a hackathon. That's cool. Yeah, it's a very popular algorithm, this k-means clustering. And there's another like similar algorithm, in a sense, called k-nearest neighbors. And they're actually two quite different algorithms. But they both rely on sort of finding what are the nearby things and minimizing. And in the case of k-nearest neighbors, you're classifying based on those nearby things. But we're actually covering the k-nearest neighbors algorithm in MATLAB. So that should be taking place on Tuesday. If anybody's interested in learning also about another algorithm that kind of looks at what's nearby and tries to make a decision based on that, check out Tuesday's MATLAB machine learning module. But for now, we're working on k-means clustering. All right, yeah. And so we have our data now. So I'm going to make a dictionary for our data. And let me show you in the slides what we want to do. We really are interested in replacing our generic plot with the eruption data that we have. So we're going to build a dictionary that will hold the data we want in neat key value pairs. And I've formatted it like this. So x1 is the first key in our dictionary. That's showing the eruption time, which will be on the x-axis for a category 1 eruption. And then category 1 I've shown is the y-axis data, the waiting period data. And the reason I named it category 1 is because I want that to show up as in my legend. You could just call it y1 and then manually modify your legend, but I just wanted to do this to make it a little simpler. And then I did the same thing for the second eruption. So just replacing 1 with 2 everywhere and putting all of this into a dictionary so that we can call it in our chart. Okay, so let's write this up here. So we first type x1 for our first key, and the values come from the category 1 data frame. And category 1 would be then the y for waiting. Okay. So now we'll type x2, which would be category 2, eruption. And we have waiting. Okay, so there's our data in the dictionary form. So we've done it. And now we're going to add a custom layout to make the plot more beautiful. So this is a way to update the look of your plot and really give the reader a much better sense of what you're doing. And for that, you're going to build a dictionary called layout, and you can pass any attribute that will be, any parameter that will be used for Plotly to specify the design of a plot. So in this case, we can use title, x-axis, and y-axis. And I'm going to get going on this with my code you also have the copy in your Google Drive if you find it hard to read that tiny text. But we'll start with layout dictionary. And the first key I wrote was title. So we'll call the title of this plot Old Faithful Geyser Eruption. And then we use the show legend key and mark that as true. Use the x-axis key, and we put a dictionary inside of the dictionary here, because the x-axis itself can have many different attributes. So we'll have eruption length in minutes as the title of the x-axis. We'll put show tick labels false, just to kind of show that you can modify it whether you want to show tick labels or not. And I put the X label. Actually, I think this is not, we don't need this part. All right. And then with y-axis here, we're also going to use a dictionary of its own. And we'll type title. And the title here I wrote as time between eruptions in minutes, just to make this plot a little bit more readable. And I got rid of the tick labels here also. Okay. So now we have our layout. And we need to build some sort of infrastructure around this. So we're going to build a page to sort of lay out this chart. And this one's going to be much bigger than last time. So it's kind of hard to see in this photo, but we're going to add some styling, add mode equals markers to show those data points as a scatter plot, and then specify the data and specify the layout. So let's go ahead and do that now. All right, so what I'm going to do is first type page. And remember from last workshop, we used 3 quotation marks to show a multi-line string. And that will just help us keep this a little bit more orderly. So we type data and then chart. And then we wrote mode equals markers to indicate a scatter plot. And x1 was x1, x2 was x2. This is showing the x data. So we want 2 different x datas, one indicated by the x1 and one indicated by the x2 keys of the data dictionary. We'll do the same with our category 1 and category 2 Y data, which are the waiting periods between eruptions. Remember that. And then we'll also do colors. So I want to distinguish between these two. I'm going to use green and blue, but feel free to use whatever colors you prefer. And a layout equals to layout. So it will substitute in for the layout there. All right. And we can delete this old stuff. We don't need that anymore. I'm just going to delete that for now. But we'll go back to our plot, our slideshow, and run the GUI. So when we run the GUI now, we will just pass in this page variable. We won't pass in a long string like we did last time, because we've already sort of done the heavy lifting with that page variable. So when you type this in and run your code, you should get the following plot. Look at that pretty plot of all of the eruptions, and it's showing the short eruptions in green, at least on mine. It might show the blue eruptions short on yours, but as a cluster kind of towards the bottom left corner. And then the long eruptions are shown at the top right in blue. And remember, we used the k-means clustering algorithm to achieve this result, which means that we had k-means clustering go through and target each of these individually. and sort of minimize the distance and individually classify these. All right. So this is great. I mean, we have some formatting in our plot, and it's working. So it's displaying our machine learning data, but it's time for the real test now. And I love to give you all a test. So I'm going to send you this quiz, which I'll paste in the chat as well. And this is going to be designed to test your understanding of what we've just talked about. Charts, eruptions, all of this stuff. All right, so let's give it a couple minutes to take this test. All right, folks. So hopefully you had a second to look at this, and we will go through the results now together. Let me pull this up. I think this is our 6th quiz. We have quite a few responses. So let me share this. Usually takes a second for me to just get my bearings. Sorry. But the question was, what library is chart built on? And 100% of you, congratulations, got the correct answer here. Plotly. Yeah, sometimes you might think Plotlib, Matplotlib, because it's so common, but Plotly is how it's done. And then I asked you to name 2 customizable attributes of a chart. And actually, you all named some really good ones here. Marker, page, value, color. Those are all customizable attributes of a chart. So excellent work. I asked, why do we use triple quotation marks to define a page? And a lot of you wrote the correct answer here. You're basically using a multi-line. So anytime you wrote multi-line, that was correct. Except here, it's not actually a comment. It's actually a string. So it's a multi-line string. You could use a multi-line string as something similar to a comment in Python. A lot of people do. So that's a super common thing to say. But in this case, we care about the input and the values of it. So it's not really a comment. And I asked, what algorithm are we using to classify the eruptions? And you all wrote k-means clustering. So excellent work on that. Yeah, but all right, so that was a little break for the test. And now we're going to add some interactivity. But first, we're going to take a quick break, actually. I'm going to go grab a little bit of water and just take about 3 minutes, because we're running a little behind if we want to finish everything. But take about 3 minutes to give yourself a break, get some coffee, take a little rest, and then we'll come back. Right, folks. All right, folks. So actually, I'm back. I actually decided to grab a little Coca-Cola, but yeah, I hope you had a little break, just a minute to stretch your legs. We've been at it for an hour and a half now, so it would be totally understandable if you wanted a little break. And actually, maybe I should have built in another break earlier, but we'll move on to adding interactivity now. And this is really why we're interested in a web app, because if we can just do this model on our own and share the results and nothing has to change, then what's the point of building a web app with Taipy, right? But really, the point is that we can ask users for interactivity. So we can have the user, we're gonna have the user add in their own eruptions, classify them, and see them in context. So they can see the results plotted, enter their own eruption, and the algorithm will tell them what kind of eruption it is. Okay, so if they're visiting Yellowstone and they saw an eruption and they want to know, hey, what kind of eruption was that? Was that a short eruption? Was that a long eruption? I don't know. It was kind of in the middle. They can come to our application and see. All right, so what you'll do first is add some new elements to your UI. And this is really important because we need to have a way to accept input from the user. So I wrote a little bit of markdown script here to add your own eruption, enter the data below, and then the eruption length in minutes and an input field. So let's test that out. Let me write that in. Let me share my Visual Studio Code again. So you go in here, and we wrote to add your own eruption, enter the data below. And then I had eruption length, which was in minutes. Typed eruption stat input, just as so. And then I wrote time since last eruption in minutes. And we said that was waiting stat input. And you might not remember these inputs if you weren't here for the last session, but we used these input controls last session to do hello world. So we asked the user, hey, what's your name? And instead of eruption stat, we had name. And we used that data in our application. So we'll put those through, and then we'll have the submit button. And we're going to have it submit a scenario function here. Use the submit scenario function. It'll call that function. We haven't built the submit scenario function yet, but we will. And we also used the submit button when we had our previous workshop, the first part, in order to trigger the hello world message. And then I'm going to put the message down here in this message text control and save. Okay. And remember, I said we need to define the submit scenario. We're actually getting an error message there, and that's exactly what we're going to do now. So, don't forget to instantiate these variables. So, I myself kind of forgot to do this. That's the next thing we'll do. So we're going to type eruption stat just to instantiate these variables that we just defined as 0 and empty strings, because remember we called these variables in page, so we need to actually have some default value for them when the page first renders. But once we've done that, we can move on to configuring the scenario. So we learned how to configure scenarios in part 1. And they consist of nodes and tasks. So we'll need several nodes. The first 2 nodes are input nodes. We have the input eruption and the waiting data nodes. So we'll give those IDs according to the variables, so eruption stat and waiting stat. And then we also have the message data node, which we will use as the output. Okay. So That sort of covers our bases as far as nodes. So let's put those nodes into our application before we go any further. I'm going to put them up here above. Well, actually, I'll just put them above the instantiating variables. So we're going to put input eruption data node. And we use config, which we haven't imported yet. So let's just import that. It just gets imported in line 4 with the other Taipy modules. And while we're at it, we're going to need another module called core. So I'll just import that as well for now. But yeah, so we'll just import all 3 of those. And we'll give them the ID eruption stat. And then this one, I will say input waiting data node. We'll also use config library and get this configure data node going. And we'll use waiting stat as the ID. Because I like to match up the IDs with the variable names. And the reason for that is because it makes it easier to do the whole submitting the scenario thing and updating the state. It just makes it easier to remember what you're doing when you have these IDs matching, as we learned that. We learned about that in part 1. And then we'll have our message data node configuration, which we will configure that data node and give it the ID message. So that corresponds to the text module. Okay, so important TTV says, my graph isn't categorizing the 2 categories correctly, and my SSE is in the hundreds of thousands. Number of iterations, 8. Well, so important, I would say, first thing I would ask you to do is plot your data and see if there's any strange thing happening with the plot. When you plot it, you should see a range. So let me show you what it looks like when I plot my data. I think I had it in the slides. All right. So, oh, actually, that's really bad because it doesn't have any axis labels. Uh-oh. All right, let me open it up live so that you can actually see it live. I think that will be better. All right, so you can probably see that live now. And the range goes from about 1.6 at the shortest eruption, 1.6 minutes, all the way up to 5.1 at the longest. So that should be the range of your eruption lengths. And then the durations should, or the in-betweens should be between 43 minutes and 96 minutes. Okay. And Port TV says, with my plot, the 2 categories are not distinct. They're mixed up as if they were categorized at random. Make sure that your parameters match the ones. Oh, also important. Try running the code that I sent via GitHub. I sent it here. I'll just send it. So try to download this file. It's specifically Taipy Workshop 2, Taipy Tutorial 2, and try running that. And that would be a good test to make sure that it's not an issue with your system, but it's an issue with your code. Because sometimes it could be an issue with your system. It can be kind of hard to diagnose. But I recommend to go to this workshop series repository and download. I'll type the name of the file, taipytutorial2.py, and try to run that file and see if you get this random categorization situation. And if you don't, If you do, then it might be some other deeper issue. But if you don't get it, I expect you won't get it. That would be good news. And then you can look at the differences between yours and mine. Okay. All right. So let's move on to the next section here. Okay, it's a deeper issue since it's still not categorized correctly. Try re-downloading the data also. Download the data from my repository, not from Kaggle. So try downloading it from here. And let me know if that works, because it might be that the data from Kaggle is slightly different somehow or formatted differently. So just use my data set, my version. Okay, so let's see, where were we? Okay, we were here categorizing and configuring our data nodes. So we already configured the input and output data nodes actually. And the next step is for us to configure our task. So I'm going to configure my task, build message task. This is the same configuration step that we did in part 1. I'm use the same exact ID, the build message ID, but now I'm going to say a different function, because before I just made this function hello world. Now I'm going to use the classify eruption function, which is a new function that I haven't built yet, but I'm going to build, and it will use the k-means clustering algorithm to classify these eruptions. All right? And then I want to tell it about my eruption data node, my weighting data node as inputs to the function, and then as outputs, we're going to use the build message data node, message data node here, and that should conclude it. Okay, and then I want to put one more configuration, the scenario configuration, and this kind of unites the tasks and the nodes together in Taipy. And we'll configure the scenario using the scenario object or scenario ID, and the task would be this build message task. Okay. Configuration. All right. So remember, I still need to define this submit scenario function. So I'm going to do that below. And we're going to have it pass in a state. Because remember, the state will be different for each user. Oh, I'm glad this worked for you, Portance. So it seems like you need to use the data set from my repository. So it's not the same. It's not the same file. Andy said I downloaded the file from the same version you shared at the beginning. It's actually not. I think it might not be, because Portant is saying it's different. And okay, TwitchW says I downloaded the file from Google and I found the colors do work. So it seems like maybe it just might vary from person to person depending on your data set and your particular code, whether you get an error or not. But in principle, it should still always create 2 clusters. It's kind of strange that it created a random categorization. That would indicate that the model did a very poor job of building these 2 centroids. And indeed, it did seem like it did make a big issue, because you had a very high SSE compared to what I had. But I'm glad it's working for you now. So anyway, let's build this submit scenario function now. And we'll go back into our slides, because I want to actually, we'll build the classify eruption file first, I suppose. This is actually what I wanted to build anyway. It's the k-means prediction function. And what it does is take in as its inputs the user eruption and user weighting data. So the state that the user passes through for these 2 variables coming from those eruption node and weighting node. And then it says if the prediction is 0, then, or is 1, really, you'll say, cool, your option is a category 1. I'm sorry, actually, that should say 2. That's an error. I'm going to fix that and push the change, because technically category 2 is when it's equal to 1. Category 1 is when it's equal to 0. So it should say, cool, your eruption is a category 2, and then otherwise, your eruption is a category 1. So let's implement that in our code. And I put that before the data nodes on line 48, but you can put it wherever as long as it's before you build all of this stuff. So we'll take in 2 arguments, user eruption and user weighting. And then we have if this prediction then return cool, your eruption is a category 2. And then else will return cool, your eruption is a category 1. So what this does is it passes these features into the k-means model and asks for a prediction. And based on the prediction, it will tell the user a different message. Okay. So now, finally, now we'll do the submit scenario. And that's where we're going to write the state into the scenario and build that. So what we'll do is take directly from the state the eruption stat variable and the weighting stat variable and write those onto our scenario. So we'll do that below the page, right where I started doing this, and then kind of got sidetracked by the other function we were building. But remember that our scenario has this eruption stat node because we called it the same exact ID. We did that for a reason, by the way, that we used the same ID. Remember I said it would make it easier, and now it's making our lives easier. We don't have to remember all this stuff. And then we do scenario.submit to build that scenario and really get it running with the tasks and everything. And then at the end, after we build the scenario, we want to read back that message, whether it's category 1 or 2, and propagate it to the state so that it can be returned to the user on the client side. Okay. And it's telling us a warning that we don't have scenario defined, and we're going to fix that. Remember from the first part of our workshop, we needed to build the scenario in this if name equals main part. So we're going to use TP to create a scenario from our scenario configuration. And then we just use GUI page.run like we did before. And it's telling us that TP is not defined. So we actually have to import this again. Import Taipy as TP, as we did in the last workshop. And then we have everything done. So when we go back into our PowerPoint here, not our PowerPoint, sorry, our Google Slides, we're ready for a demo. And you can see I've tested this out. Hopefully it works for you too. We should now be able to allow our user to enter in the information associated with their eruption, and it'll tell us whether it's an eruption 1 or 2. And heck, why not look at this ourselves, right? So let me run this and you can see the live demo. So here's my Taipy app. Zoom in a little bit so you can actually see. Put myself in the bottom, maybe. zoom in even further. And yeah, so I'll just type in the eruption. I'll just mask myself out so you can see. So let's say the eruption I witnessed was 3 minutes long, and it had been 60 minutes since the last one. So I type submit, and it tells me your eruption was a category 2. And that makes sense because this is right about where my eruption would be. So it would be a category 2. All right. So hopefully this workshop gave you a sense of how to use this Taipy framework. And I want you to now have an at-home challenge. So the challenge is, can you plot the new data point on the chart? Use red or some other color to distinguish it from the original data set so that users can see their volcano or eruption plotted in the context of all of the other data. All right, we have a wrap up, and the wrap up is going to be a final survey, one last quiz for you all. And this one is probably the easiest one we've had. It's just asking you to tell me a little bit about what you learned today. So tell me one thing, anything at all, that you learned from the workshop. And remember, the completed code final product is available on Google Drive, and it's also available on this GitHub repository that we spun up during the workshop. All right, so we have a few responses here. Folks saying they feel a little more confident, which is great. And some things you learned were including Taipy, sklearn, and how to design plots. So that's great. It seems like you all took away. My goal was to have you take away something about Taipy, and that's great that you all felt that way. So, all right, that will conclude it for today's workshop. But I really appreciate you all sticking around, especially those of you who were here for part 1 as well. And don't forget, we have some more workshops coming up in Global Hack Week. Check the schedule, ghw.mlh.io/schedule, if you want to learn more about what is in store. And yeah, that's it. Take care, everybody.